So this session is going to be, so first one is image, Dockerfile creation. So here is the Docker desktop, run. Hello everyone, a very warm welcome to Think Constructive. I am Isha. In this session, I will be discussing how to Dockerize Java Spring Boot application. So this session is going to be very helpful for all the Java Spring Boot developers, technical lead and technical architects. In this session, I will be starting with a quick overview of Docker, which will be followed by the detailed demonstration of Docker. Alright, so stay tuned. Watch the session till the end so that you are not going to miss upon on any of the core concepts. Alright, so let us quickly start with the Docker overview now. So Docker is an open source platform and it is used for developing, shipping and running applications. So what happens, Docker helps you to separate your applications from the infrastructure so that software can be delivered quickly. Docker helps you to package all the dependencies with your application as a one single unit, which you can ship to the platform team, to the testing team, or wherever it is needed. Alright, that is one extremely important reason that Docker has become so popular. Here are some key features which I have displayed on the screen for your ready reference. Alright, here are some important terms which you should know if you are working with Docker. So first one is image. So what is the image in terms of Docker? A Docker container image is a lightweight standalone executable package of software. That means whatever application you are writing, when you build the Docker image, that will have your application, all the related libraries, dependencies, everything which is required to run or to execute your application code. So in our case, we will be doing the demonstration with the help of Java Spring Boot application. So this will be the executable package which will have to execute our Java Spring Boot application. Alright, another important term is a container. So what is a container? It is a standard unit of software that packages up code and all its dependencies so that application runs quickly and reliably from one computing environment to another. Third important term is Docker container. So what happens? Docker images becomes containers when they run on the Docker engine. That means in simple terms, if I talk about when you execute your Docker image, it becomes Docker container. Alright, so here are some important Docker commands which we will be using in our demonstration, and also you should know as a developer if you want to work with Docker. So first one is Docker images, then Docker build, Docker run, then we have Docker tag, then Docker push, Docker pull and Docker ps. So these commands, in addition to these commands, there are some more commands which we'll be using in our demonstration. Alright, so let's talk about Docker workflow. So first step is developer writes the code or create the application. Now the application is ready. Now the next step, developer wishes to Dockerize the code or Dockerize the application. In order to do so, he or she should write the Dockerfile. Dockerfile is a simple textual file which will contain the relevant Docker commands, right? The next step is Dockerfile creation, that is done. Then third step is Docker image should be created. So whatever instructions are given in the Dockerfile, basis on that a Docker image will be created, wherein the application, the created application by the developer and all the relevant dependencies, libraries will be packed, right? The another step is now once the Docker image is ready, it has to be executed. So how the Docker image will be executed? One option is you can execute it directly in your local machine, or if you wish to distribute it, so what are the steps? You can push it to Docker Hub, and from Docker Hub it can be pulled to different environments wherever you wish to execute this image. Alright, so here are certain steps which we will be covering in today's demonstration. So what I will be doing, we will be creating a simple Java Spring Boot application, then we will be writing Dockerfile for the created Spring Boot application, then we will be building the image for this application which we will write, then we will execute that image in our local machine, and also we will push that image to Docker Hub. We will pull the image from Docker Hub and execute the application. So we will be seeing all these steps in this session itself. So watch the session till the end, and I would highly recommend you, if you follow along, if you do all the things along with the session, that will be extremely helpful for you. Alright, so let us start with the demonstration now. First step, we will be building a simple Java Spring Boot application. For building Java Spring Boot application, let me just quickly bootstrap the Spring Boot application using a Spring Initializer. Alright, so here is the Spring Initializer. I'll choose a project as Maven, language as Java. Packaging, I would go ahead with jar, Java 22 version. Let me choose a Spring Boot 3.4. Group name will be com.thinkconstructive, and let me give artifact name as Docker demo. Okay, and description is Docker demo for Spring Boot app. Okay, so let us include the dependencies. So we'll just build a simple REST application. So I'll just choose dependency as a Spring Web, and then I would say generate. Okay, so Docker demo zip is downloaded. Here I have extracted the project which we have generated through Spring Initializer, and you can see my project is synced up. I'm using IntelliJ IDEA editor. You can use any Java editor of your choice. Alright, so here let us quickly see the project structure, what we have got. So in src main Java, under com.thinkconstructive Docker demo, you can see Docker demo application is there, and a basic skeleton is given to us. Alright, so let us quickly create a controller class here. So we will say, let's say Docker demo controller. Alright. So let us, since we are creating a REST controller, let us first annotate it with REST controller. Okay, and inside this, let us create a GET API. Let's say my GET API returns a string. So I would just say public string GET demo. Okay, and inside this, let us simply return a string message. Okay, Spring Boot app is Dockerized successfully. Okay, fair enough. Yeah, and let us mark this GET API with GET mapping, then only it will be treated as GET API. Okay, and we'll just give the Docker demo. Okay, so we have created a GET API which will be giving me this message if the API is up and running successfully. Alright, so let me just save this and let us quickly run the Spring Boot application and see what happens. Okay, first we'll test it as a normal Spring Boot application, that means without Dockerizing it. Okay, and then as a next step we will Dockerize it and see the things. Alright, so let us run this application. And as you can see here, Tomcat started on port 8080 and started Docker demo application. Alright, so let us go back to browser window and check whether this application is up and running or not. So since it is on the local machine, so I will just give localhost port 8080, alright, /docker demo. Okay, hit enter. So what am I getting? A Spring Boot app is Dockerized successfully. So this is the same message which we return here. Okay, it's just a simple get API, which is returning me some message so that I can know my application is working fine. Alright, so let me bring down the application, and next step we will start writing the Docker file for this application. Before that, I just would like to tell you that if you would like to learn Spring Boot in more detail, there are many sessions on Spring Boot available on my channel. So details of those sessions, the complete playlist is getting displayed on the screen right now. Feel free to explore those sessions and understand Spring Boot in detail. Now the next step is, let us build the jar for this application. For that, let me just open the terminal window here itself. And here, since it's a Maven project, so I'll be just giving the Maven command. Okay. And this will create the jar for the project for us. All right. So you can notice the build is successful. All right. And here you can see the target, inside target, docker-demo-0.0.1- jar. Alright, so this is the place where the jar is created. Let us go ahead and check. Inside target folder, you can now notice the Docker demo jar is available. Why have I created this? I'll just tell you in a while. Okay. So let me just minimize the terminal window. Now the next step is, let us create the Docker file. Where should we be creating that? We will be creating Docker file in the root path of the project. Okay, it's a plain textual file. I'll just select file and I will just say Docker file. Please note the name Docker file should start with capital D. Okay. So inside this, what I'll be doing, I'll be writing now a set of instructions which will be used to build the Docker image. Okay. So first instruction I'll be writing from, here I should be mentioning the base image which my Docker image will be using. So the base image which am I supposed to give here is the Java image, because I am building a Java project. So I should be giving a Java image name here. Okay. How should I get the Docker Java image? For that, let us go back to browser window. And here I will be writing, let's say, Docker image. All right. And inside this, I will go to hub.docker.com. You can directly come to this site also. That is also fine. I will just say search Docker Hub. And in that, I will say Java, because this is the image which I need. Okay. I'll go inside Java. And here you can notice there are certain Java official images are mentioned. Let me just select the Amazon Corretto. Okay. And this is the image which I will be using. Okay. So I'll just give this, and with Java version I would want 22. All right. Next one, I'll be writing some metadata with the help of label. Okay. So notice this from, label, all these things are fixed. This is how you should be writing the instructions. All right. So let's say I just want to give version. Okay. 1.0. All right. Next, what I would want, I want to expose the port. Okay. So expose is a command. For that, I will write 8080:8080. So this one is the application port when it will be up and running in the container, and this port is for the host machines port. All right. Then I need to give work directory, that is work dir, where so inside the container there should be some work directory, base directory that we should be mentioning. So let's say we mention /app. Okay. Then we should copy the jar file from source to destination. Okay. So for that there is a copy command. Okay. And where is my jar file? Inside the target. Okay. So I'll be writing target / I'll just copy this jar file name. Okay. All right. And then we'll copy that in app, which is my working directory in container, and the jar file name. All right. So I can give jar file name as it is, or if you want to shorten it, let's say something like this, I can do that. Okay. So from source to this destination, jar file will be copied. Okay. And the entry point. And entry point format will be like this. Inside square bracket, the executable details should be mentioned. Okay. So I'll just say Java -jar. Okay. And then the jar file name. Alright. So jar file name should be this one, because this is the destination jar file name. The same it will be picking for execution. Alright. So these are the basic details we should be mentioning in Dockerfile. Okay. Let me just save the file. So my Dockerfile is ready. Okay. So what we have done, we have created a simple Java Spring Boot application, created the jar for this, and then we have written Dockerfile. Alright. What is my next step? So the next step is build image with the created application. Alright. For building the Docker image, Docker should be present at your machine. So for doing so, I'll just show you, if you don't have Docker already, how you can install it. Okay. You'll just write Docker install here on the browser window, and you can see get Docker here. Okay. So from get Docker, you can download Docker basis on your machine. And please note, I am telling you to download Docker desktop, because along with the Docker desktop, Docker will be installed definitely, and Docker desktop will provide you a wonderful UI with which to manage the images and other activities of Docker are much simpler. Alright, for my machine I have downloaded Docker desktop for Mac. If you are using Windows or Linux, you can download the file accordingly. Alright, after downloading, the installation instructions are simple. So you can just follow along and install the Docker at your machine. Alright, in my case I have already downloaded the Docker. So I'll just open the Docker desktop and will start demonstrating how can you build the Docker image. Alright. So here is the Docker desktop which I have already installed, and I have logged in. So after installing Docker desktop, you just need to enter your Docker credentials. If you have not yet created, you can directly create it from here. Okay. So since I have already logged in, it is showing me my personal ID here as Think Constructive. But for you, it might be asking you for sign in or sign up from here itself. Alright. So currently I only have dummy service here in my container and some basic images. Alright. So now my Docker is up and running at my system. So I have opened the terminal window here, and you can see my Docker demo project is here. So I'll quickly change the directory for this. Okay. And here it is. So I have opened the terminal window because I am using Mac operating system. If you are using Windows, the command window would work for you. Alright. And for Linux, it's the Unix terminal. Alright. So here is my project Docker demo, and inside you can see Dockerfile is available. This is mandatory for building Docker images. Alright. For building the Docker image just with all the defaults, what should I do? I'll just give Docker command. Okay. So Docker build dot is current path. Alright. So from this current path, it will read the Docker file, execute the set of instructions and build the image. Okay, before that I will just show you if any images are available on my system, which we have just now seen via Docker desktop. I'll just show you it via Docker images also. So whatever images are there, Docker images command would display them. Alright. Now let us build the Docker image. Docker build dot. From current path, it will read the Docker file and will build the image. Alright. So you can see it has started building the image. It will take couple of seconds and will build the image. Alright. Okay. So view build details, here it is saying that means my Docker image is built up. You can notice here the commands what we had given in our Dockerfile are executed here. You can notice we used Amazon Corretto image for Java, so it is pulling that, okay, and then you can notice work directory is changed to /app, and then jar file is copied from target directory to /app, okay, and then images are exported. All right, now let us execute docker images command. Okay, now you can see this is the latest image which is built. All right, but since we have not given any image name or any tag name, so image is built up with none as name and none as tag, which is definitely not at all a good practice. Okay, we can still work with image ID. So in order to do a proper image, in order to create a proper image, how do we do that? I will just say docker, okay, command would remain as build, and then I will do tagging. So for doing the tag, I should give -t, and then the new image name I should be writing. I can give it as Docker demo. Let's say image 1 I am creating, okay, and then I will give the tag name tag 1, okay, and then from where I want to build this, I will just say dot, that means current path, okay. So my new image is also ready, okay, it has executed all the important stuffs. Now this time it is not pulling Amazon Corretto version 22 Java because it has already pulled it up. All right, so I will just say docker images, okay, and let us see what is created now. So you can see docker demo image 1 tag 1 is created, okay. So what it has done essentially, if you notice the image ID this and image ID this are same. That means the default image which it created without giving any repo or tag name, it has actually renamed the repo and tag for the very same image. Now let us open our Docker desktop window and see how many images are there. So you can notice Docker demo image 1 and tag 1 is displayed here now. All right, now we have built Docker image. Next step is to run the Docker image at the local machine. Okay, so let us see how can we do that. So for running the Docker image at your local machine, the command is docker run. So let me just clear the terminal. Okay, let us now again display Docker images. Okay, so we have created this image and now we would like to run this image. How do we do that? So what should I do? I will just say docker run because docker run is the command for that. All right, I will give the port name as -p 8080 for host machine port and 8080 for my containers port on which the application will be listening. All right, and then I will be writing the Docker image name, okay, that should be followed by the tag name. If I will not give any tag name here, by default it will look for latest tag, okay. So let me just show you that what happens. So you can notice unable to find image because image name exists but not with the latest tag, okay. So it will show me an error. So now let us proceed and put the tag name here, which is my tag 1. All right, and now let us hit enter and see what happens. What happens now? You can see Tomcat started at port 8080 and started Docker demo application. All right, so let us now check whether its get API is working fine or not. So let's go back to the browser window and see localhost :8080 Docker demo, enter, and you can notice the Spring Boot app is Dockerized successfully. All right, so my application is up and running. in the Docker container. Alright, this is what we wanted. So now let us bring down the application. How do we terminate it? We will just say Control C. Okay, so Docker is terminated. So Docker container is terminated. Let us go back to Docker desktop and see if any container is up and running. So you can notice some container, some name it has given. Okay, it allocates it randomly. So the container was up and running on port 8080. Okay, now the status is exited. Alright, now the next step is push image to Docker Hub, and then we will be pulling image from Docker Hub. Okay, so let us now see what is Docker Hub. So I am back to the browser window. I'll just tell you what is Docker Hub. Docker Hub is the cloud container registry. That means as a developer, you can push your images to the Docker's cloud, okay, and can distribute from there wherever you want. So you can make it available on the public distribution as well as private distribution. Okay, so for Docker Hub, I will be writing Docker Hub here. Okay, I'll get the first link as Docker Hub container image library. Alright, so this is my hub.docker.com. Okay, and herein you should have your account. Okay, in my case I have already created one, so I will just sign in. So I have signed in to the Docker Hub. Okay, so for pushing the images to the Docker Hub, which is the cloud place for Docker images, you should have your Docker Hub account. Okay, and you should log in there. Okay, so now I will just say repository here, and here you can say think constructive as a namespace is coming. Okay, now let us go back to the terminal window. Okay, and let us now push the created image to the Docker Hub. So let me just clear the terminal window and again display our Docker images. Sorry, Docker images. Okay, and you can see my Docker demo image 1 with tag 1 is here. This is what I would like to push. So before pushing, I should be tagging the image, and then the tagged image can be pushed to the Docker Hub. Okay, so it's a two-step process. First is tagging and then pushing. Okay, so how do we tag the image? I will just say Docker tag. Okay, I'll give the image name here. Okay, that should be followed by the tag name. So this is the source image and tag, and then the new repo followed by the tag name. So new repo name we just now created. Okay, think constructive, then the image name. Okay, and followed by the tag name. Okay, any tag name I can give. In our case I am just giving tag 1 here. Okay, I'll hit enter. So let us now again see our Docker images, whether it is tagged properly or not. So now you can see think constructive / Docker image with, oh, I have given tag 11. Okay, let it be. So with tag 11 is created. Now the next step, once it is tagged, we can push it to the Docker Hub. Okay, so I will just say Docker push. Okay, and I'll just copy this image name. Okay, followed by the tag name. Okay, so it is tag 11. Okay, I'll just hit enter. So it will take couple of seconds for pushing. So you can see it's pushing the image, it's mounting the library, and all the steps are getting executed. It will take some time. Yeah, so there you go. Tag 11 digest SHA-256 is created. So let us now go back to Docker Hub and check. Alright, so now you can see here think constructive Docker demo image is available. Alright, we can go inside and check the details. So tag 11 image is here. Okay, and if you would like, you can write an overview or and short description, etc. Whatever you want, you can write the detailing here. Alright, so currently we have Docker demo image. Okay, Now the next step is we will pull this image from Docker Hub and run the application. Alright. So let us pull this image from the Docker Hub. How do we do that? We will just say docker pull, okay, and then we will write the image name what we have pushed, okay, and probably for more clarity let me just do one more stuff. Let me just delete this tagged image because the same thing we have pushed and same thing we will pull, so you will not be able to understand the difference. So let me just remove this. I will just say docker RMI, okay, and I will give this image name, okay, that should be followed by the tag name which is tag 11. I will hit enter, okay, so it is untagged, it is deleted. Now let us again see docker images, and you can now notice the thing constructive / docker demo image is gone, it is removed, okay. We can verify this from Docker desktop as well. So here you can see the tag 11 image is no more available. Alright. So now from terminal window what will we do? We will pull the image now. So let me just clear the window, okay. Now what is the command for pulling? We will say docker pull, okay, that will be followed by the image name and then tag name, okay. So now what is the image name? Let us take it from the browser window. So this is the image name. Probably we can copy this from here itself, okay. I'll just give, and that should be followed by the tag name which is tag 11. Alright, let us verify it once more. The tag 11. So wherever you will not write the tag name, remember it will look for latest. If it is not available, it will throw an error. Okay, so for now I am just pulling think constructive / docker demo image :tag 11. Hit enter. It will take some time to pull down the image. Okay, what does it say? Docker this is done. Okay, so let us now verify with the Docker images. So now you can see this image is here. It is just now pulled. Okay, we can check it from Docker desktop as well. Fine. So now again let us execute this image and see whether it works fine or not. So for that doing so, we will just say docker run -p port 8080 :8080, alright, and then the image name followed by tag name, so tag 11. We'll hit enter, okay, and let us see. So my application is now up and running, okay. Tomcat started on port 8080, started Docker demo application, okay. So we'll come back to browser window. We will again open this localhost 8080. I'm just refreshing and you can see it's working fine. Alright. So what we have done? We have pulled the image and executed it at our local machine. Similarly, you can pull this image at any machine, staging, production, wherever needed, and you can execute it as it is on any of your peer developers machine, on your tester machines, anywhere you can pull this image and work with it. Alright. So what we have covered in this session, we started with Docker overview, followed by bootstrapping a simple Java Spring Boot application, Dockerizing the application by creating its Docker image, running it in local machine, then pushing it to the Docker Hub, pulling it from Docker Hub and again executing it at your local machine.
Congratulations, you have successfully Dockerized your Java Spring Boot application. If you have any doubts, please ask your doubts in the comment section below. Share this session and channel details with your friends and colleagues because that will help us to grow as a community together. There are more Java Spring Boot and microservices sessions available on the channel. Feel free to explore them. Thank you everyone. See you in the next session. Bye for now.